Hey folks, welcome to my channel Number Pen. There we have the problem on our screen. If f of x equals mod of x plus 100 plus x square, test whether f dashed of minus 100 exists, right? So what do we mean by test whether f dash exists at a particular point? In this case, it is minus 100. All that it means is find out whether this function is differentiable at the point x equals x naught, and in this case, x naught equal to minus 100, right? And if an f dash exists, then our right hand derivative and our left hand derivatives will be equal, right? So, what before we establish our right hand and left hand derivatives, we have some work to do because it has a mod function. A part of f of x is a mod function, which is mod of x plus 100. So, let's rewrite the equation. We know the definition of mod function. So, let's write the function accordingly. F of x has to be defined as x moves through minus 100, right? And why is that? Because our function mod of x plus 100 plus x square will undergo a transformation at x equals minus 100. And why is that? Because mod of x plus 100 takes a value x plus 100 for x greater than or equal to minus 100, right? So let's write that. That will be our first part of the equation, x greater than or equal to minus 100. And then my mod of x plus 100 takes a minus of x plus 100 plus square for x lesser than minus 100, right? So there we have our expression. With this, we will move on to our LHD and RHD, right? So let's do our RHD first. So there we have our RHD. RHD equals f dashed of x naught plus equal to limit h tending to 0 f of x naught plus h minus f of x naught divided by h, right? And what is my x naught in this case? My x naught is minus 100, right? Minus 100. So I can replace x naught with a minus 100 plus h, and there we have our expression on the screen. And what is my first part of the numerator, which is f of minus 100 plus h? It is when x takes a value which is greater than minus 100, but by an infinitesimal h tending to 0. So, which means my f of minus 100 plus h is going to take the first equation, right? Which is x square plus x plus 100, right? I'm just rearranging it. So let's write that out. And what do we have in place of x? In place of x, I have minus 100 plus h, right? So let's substitute wherever we have x by a minus 100 plus h, right? And then we have our f of minus 100, right? So what is our f of minus 100, right? So let's calculate that because that's going to come in handy for both our LHD and our RHD, right? So let's write that separately because it is a quadratic equation. Let's write that out. My f of minus 100, again, it is going to take the equation which is highlighted in yellow, right? Because that equation is applicable for all x greater than or equal to minus 100. So wherever I have x, I can comfortably substitute it by minus 100, right? And what is this? Minus 100, the whole square. right? So my 100 and 100 gets cancelled, and I have minus 100 the whole square as my f of minus 100, right? So let's retain it like that, right? And let's see what do we get as we substitute it in the RHD, right? So this is my f of minus 100, and I'm going to go back to my RHD and do that particular substitution, and I have a minus 100 the whole square, right? And then I have my h in the denominator. So I have a long expression, I think that calls for my pencil to do a bit of cancellation. So my 100 and 100 get cancelled out. And then I move on to my next step, and I'm going to rewrite this and further expand my numerator. Let's see what do we get. So my h is retained as it is, and my minus 100 plus h the whole square is nothing but of the format a plus b the whole square, right? So I think we can further expand that. So let's do that. And what do we get? My minus 100 the whole square is nothing but minus 100 square, right? Which is my a square plus my b square, which is a h square, right? So all that I'm doing is I'm using the formula a plus b the whole square equals a square plus b square plus 2ab, right? So this is what I get. And then I have my 2ab as 2 into h into minus 100. And what is that? Minus 200h, right? And then I still have my f of minus 100 along with a negative sign here. So I'm going to copy that as it is and have my h in the denominator still. It looks like we can do some more cancellation. Your minus 100 square and minus 100 square gets cancelled out, and that leaves us with, let me expand this further. My h square remains as it is, and my h can be combined with my minus 200h, rewritten as minus 199h, right? And that's all we have in the expression, right? And then I have my h in the denominator. Looks like I can pull out a h and cancel out the h in the denominator. So let me do that, and I have it as h into h minus 199 divided by h. My h and h gets cancelled out. I'm left with h minus 199. I don't think we can further simplify this. I do a substitution of h equals 0. I'm left with minus 199, right? So that is our RHD, right? Right. So now let's move to our LHD, which we will work out in a very similar fashion. So there I have my LHD written on screen. F dash of x naught minus equal to limit h tending to 0, f of x naught minus h minus f of x naught divided by minus h, right? So what is my x naught? My x naught is minus 100. So let us substitute x naught with minus 100. And now that we have an expression on our screen, which we will have to further expand by substituting x with minus 100 minus h, right? So what is f of minus 100 minus h, right? And it is when x takes a value which is lesser than minus 100, but by a very infinitesimal h tending to 0, which means I will have to apply this equation for considering f of minus 100 minus h, right? So I'm going to do that substitution. Let's further expand the first part of the numerator. So I have my expression as minus of x plus 100, right? And when I do that, I do a minus 100 minus h because I'm substituting my x by minus 100 minus h. And then I have my plus 100. And then I have my minus 100 minus h the whole square, right? So then we still have our f of minus 100 to be done, right? So we worked this out earlier, and our expression, our value for f of minus 100 is going to be the same. It is not going to change. So let's just do a quick substitution of that. So I've got this on your screen here. So now I have a long expression which looks like I can cancel out my 100, right? So I take my pencil, I cancel out this 100. I still have my expression which can be further expanded. So we will do something similar to what we did while doing our RHD. So my numerator is a minus of minus h, which becomes a plus h. The 100 has been removed. And then I have my minus 100 minus h the whole square, right? And what does that mean? Actually, I can pull out that negative sign, and negative sign, the whole square becomes a positive sign, right? So when I rewrite this expression, I can comfortably write it as h square plus I have a 100 square now, and then I have my 200h, right? And then I still have my 100 square retained. Remember, folks, we have a minus h in the denominator. And what does this further mean? This also means that I can do a bit more of simplification, right? So my minus 100 square is the same as 100 square, right? And why is that? Because my minus 1 the whole square, let me highlight that, this and my 100 square, this both are one and the same, right? And we know why is that, because my minus 100 the whole square is nothing but minus 1 the whole square into a 100 square. My minus 1 the whole square is nothing but a plus 1, so I don't have to worry about my 100 square because this moves out again. So let's take our pencil and let's cancel that out, right? Now I have a h square plus I can combine my h and 200h. That leaves me with a h square plus 201h in the numerator, right? So let me write that divided by minus h. I can pull out my h from the numerator. That leaves me with h into h plus 201 divided by a minus h, right? And Cancel out my h and h, which leaves me with minus h plus 201. And I don't think we can further do any simplification. And when I do a substitution of h equals 0, I'm having the final answer here with me, which is minus 201, right? So we have calculated our LHD, and I'm going to highlight this, folks. It is minus 201. We calculated our RHD. It saw that it is a minus 199, right? So LHD very clearly not equals RHD, right? Function is not differentiable at x equals minus 100. So the way to call out the final answer is go back to the question. If dashed of 100 minus 100 does not exist, right? And that's how we write the final answer. So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.